Hey, congratulations. You made it past workshop 1 and now you're on workshop number 2. At least I hope you did workshop number 1. So I'm looking at the agenda and there will be a link to this video right here. Now that you've learned how to decode a chemical formula, now we're going to learn about decoding chemical reaction sentences. So you're watching the workshop video. There's going to be another chunk of text for you to read and another drill and practice notes worksheet. And remember, I need both of these things done completely before our Zoom on Thursday. So let's go right back into the slides and pick up where we left off. All right, today's warm-up is currently on the screen. So if you need to pause and find your warm-ups paper, I need you to go back into the last workshop and remember what the difference is between a subscript and a coefficient. So take a minute, think about that. It is going to be really important in understanding chemical reaction sentences. All right, so today we are going to talk about different kinds of reactions. There are actually 3 types of reactions. And your book has several examples. My slideshow here has a few examples. I do plan on doing these as a demonstration in the Zoom. And then in the assignment, you're going to look at the types of reactions that occur in a firework when it's exploding. So we generally break it down into 3 kinds of reactions. So the first kind is when 2 or more substances are put together to make one or more complex molecules or compounds. So synthesis means to build. Okay, so I have magnesium, and I will be showing magnesium again. If you burn it, it combines with oxygen in the atmosphere to make magnesium oxide. Okay, so 2 things or more put together to make a more complex compound. The second kind of reaction is kind of the opposite of synthesis. Decomposition means to break down. So taking one complex molecule and breaking it down into 2 or more simpler molecules. So this one we talked about quite a bit in workshop number 1. If you put peroxide on your skin, it bubbles up, which is turning into water and oxygen gas. The third kind of reaction is my absolute favorite because it produces some pretty cool demonstrations for showing classes how replacements work. It often occurs with different metals where you can get 2 or more elements to switch places. So they essentially replace one another. Okay, the one you're going to see here in a little bit is the replacement of copper and iron. So you can see from the formula, you can take pure iron. I'm going to use an iron nail, and you can put it in a solution of copper sulfate. Now, this is a really pretty blue liquid solution. It does not look like metal copper at all. It's blue. But when you do that, the 2 metals react and they trade places. The iron replaces the copper, and so the copper comes out of the solution and attaches to the nail. It's really crazy looking. Replacement reactions happen all the time between 2 metals that can trade places in compounds. Okay, so the drill and practice for today is not side 2 of the worksheet. I had to make a separate Google Doc. You're going to use the book, and you can use the rest of the slides, which I'll go over in just a moment, to document at least 2 of each type of reaction. Okay, and if you need to use the web, you're more than welcome to do that. You'll find lots and lots of results. And I'd like you to get used to practice decoding chemical equations. Okay. So this is what you'll see in your drill and practice sheet today. It's like a little flow chart: synthesis, decomposition, and replacement. And here are some pictures of some of these reaction sentences. Okay, I'm not going to ask you to write this out on paper, but you can certainly come back to this slide to type in your document for practice. So if you're like me and you get really picky about the little subscript numbers, if you want, you can subscript them using your, I think it's formatting text. You can make it subscript. But if you don't, it's not the end of the world. If it's not subscript, I'm not gonna say it's wrong. But let's take a look at some of these. You can actually take hydrogen and oxygen gas, run electricity through it, and make water. That's what this one is. Hydrogen gas plus oxygen gas is liquid water. If you want to use this as an example in your drill and practice, you could write the formula out in symbols, or you could write it out in words. Either one works for me. This demo that I'll do is magnesium, burning magnesium. It's combining with oxygen. Magnesium plus oxygen makes magnesium oxide. Okay, I'm going to skip the middle just a second. Come over here to the decomposition. There's our peroxide one. Hydrogen peroxide breaks down into water and oxygen. Ammonium nitrate, which is a common ingredient in fertilizer. Ammonium nitrate actually decomposes or breaks down into nitrogen, oxygen, and water, which is great for soil and the plants. Okay, this is a copper carbonate solution. So Cu is copper, and the CO3OH2, the carbonate part, can decompose into copper oxide, carbon dioxide, and water. Okay, lots and lots of examples for your notes today. Now, I want you to check out this middle and look carefully. I color-coded this for you so you could see which two metals were switching places. Okay, this is the one I just talked about. Iron and copper can trade places in this situation. Okay, this one's pretty neat. Magnesium pellets in hydrochloric acid will actually create magnesium chloride, hydrogen bubbles. And if you were in class with me, I actually did this last year. I did it in a test tube and kind of walked around the room with it. The bottom of the test tube gets very, very warm. This is an exothermic reaction. It actually produces heat. It's pretty cool. This one, tons of fun. This is a reaction between silver nitrate and salt, sodium chloride. Silver nitrate is a solution, it's clear liquid, but it actually has silver in it. And if you let it sit in a closet for a long time, like my chemical closet, the inside of the flask actually tarnishes, just like silver, like real silverware tarnishes. And so there's actually silver metal in this solution. It'll change places. It makes a solution of silver chloride and sodium nitrate. So there's another replacement between silver and sodium. All right, so I'm going to show you guys what I have done before. I'm super thankful that I have these pictures from previous years, just in case you can't see these demos in the Zoom. All right, here's an iron nail. Here's that really pretty blue copper sulfate solution. And after, this is pretty cool. If I let this sit for a long time, this blue solution becomes completely clear. It turns completely into iron sulfate, and this nail becomes pretty much caked with pure copper. Okay, here's another replacement. These are the little magnesium pellets I was talking about, just some dilute hydrochloric acid, and it bubbles and it fizzes and this thing gets really warm. These black dark gray pellets actually become like a shiny silvery gray solid. And the hydrogen gas that comes out is really flammable. And if you mix too much of this, the heat produced can actually ignite the hydrogen gas. You have to be really careful. All right, here's this silver nitrate. I was telling you, tarnished. This is really old solution of silver nitrate and salt water. And what you get, and this is unfortunate that you can't see this in real life, there is a powdery looking white substance that forms. This is called a precipitate. This is liquid. This is liquid. They come together. Boom, solid, out of nowhere. The liquid left behind is the sodium nitrate, but the silver chloride is this salt. at the bottom of the test tube. And that's pretty cool because we will see a precipitate in our lab coming up in lesson 3. Okay, so before I get to the graded activity, I want to take you back to the lesson plan. Okay, this workshop will be linked here. There's some text for you to read on the different kinds of reactions. This is your online notes for today, and it's really, really easy to fill out because I gave you lots of examples in the slideshow. And something happened with this picture. I don't know, some of the words got hacked off, but you can see the real picture in the slides. Here's a link to the text. You can write in words or in symbol forms 2 examples for each reaction. So 2 synthesis examples, decomposition, and replacement. Now, if this sort of thing really interests you, I used to teach how to balance written can't even talk. How to balance and write chemical reaction sentences. And I put a little challenge in the slides and at the end of the graded assignment today. It reminds me a lot of Sudoku. I think it's a good exercise for your brain. So if you're like ahead of schedule and you really want to challenge, go to the slides. The challenge is on, boom, slide number 34, balancing chemical equations. So let's get to the graded activity, okay? I would suggest waiting until after the Zoom to do this graded activity. That way you have had all of your questions about these 2 workshops answered. And if anything is unclear, then you can have your questions answered. What I'd like you to do for this graded assignment, I want you to watch this video on the chemistry of fireworks. It's about 6.5 minutes long. It's an awesome video. Lots of chemicals being demonstrated that I wouldn't even dream of having in my chemical closet, okay? And then you're gonna do this worksheet. And it's actually not very long. I just want you to take your time and read about it because this is where you're really gonna get into some understanding of why fireworks explode and how they work. It's really a chain reaction of several chemical reactions. So you can see the video is linked here. Watch the video first. Then you can read through the article. You can use the highlight tool to find answers. You're going to practice reading some chemical equations. Easy peasy. And this ends up being worth 12 knowledge and thinking points with the opportunity for extra credit if you can identify if there are any synthesis, decomposition, or replacement in there. Now, this is where you stop copying for Echo. If you want that challenge, here are some challenges in balancing equations, and I found something at the Khan Academy. So please don't copy and paste that into Echo. Okay, this is under benchmark 2, lesson 2, and there was a lot of stuff to do for the workshop, but really this is the only graded assignment that you have for lesson 2. So there's a challenge. If you get extra time, you can keep working on researching your elements. We are not doing this collaboration activity, but I did put that 6-minute video in before your worksheet for this. And there's no team management log, but you can always go ahead to the next lesson or get caught up on other work. So again, this is the end of workshop number 2. We will talk about both workshops at the Zoom and hopefully do a few cool chemical reaction demonstrations.